So we will talk about how to use properties of quadrilaterals to prove that specific shapes are parallelograms, rectangles, rhombuses, or squares. So first, just going through the properties that you had in your notes, we want to make sure that we know which ones are true for which shape. So both pairs of opposite sides are parallel. That is a parallelogram property, which means that it is true for rectangle, rhombus, and square because they are all in the parallelogram family. Opposite sides are congruent. It's a parallelogram property, which means it is true for all four. All sides are congruent. It is not a parallelogram property. It's not true in rectangles, but it is in a rhombus and a square. Now we're going to talk about the angles. The sum of the angles is 360 degrees. That is true for all four-sided shapes, so that means it's true for all of these. Opposite angles are congruent. That is a parallelogram property, so that means it is true for all of them. All four angles are right angles. That is not true for parallelograms, but it is for a rectangle, not for a rhombus, but it is for a square. Consecutive angles are supplementary. That is a parallelogram property, which means that it is a true for all of them. Now we're going to talk about the diagonals. The diagonals bisect each other. That is true for all parallelograms, so it's for all of them. The diagonals are congruent. That is true only for a rectangle and a square. Diagonals are perpendicular. It's true for only a rhombus and a square. And the diagonals bisect opposite angles. It's true for a rhombus and a square. So if we're going to prove that a quadrilateral is a parallelogram or a rhombus or a rectangle or a square, your goal in that proof is to show that the definition for that specific shape is true. So that means that the last reason in your proof should be the definition of that given shape. So here's our list of definitions for those shapes. Parallelogram. Both pairs of opposite sides are parallel. So if we're trying to prove that a shape is a parallelogram, the goal is to show that both pairs of opposite sides are parallel. For a rhombus, we want to show that there are four congruent sides. For a rectangle, we want to show there are four 90-degree angles. And for a square, we want to show there are four congruent sides and four 90-degree angles. So let's look at an example. We're told that angle 1 is congruent to angle 4, and angle 2 is congruent to angle 3. So our goal is to prove that ABCD is a parallelogram, which means we need to show that two sets of opposite parallel sides. So that is our goal. To be able to show that I have parallel sides, I'm going to use the angles that are given to me. So if I want to use angle 1 and angle 4, the sides that make up those angles go from BC, AD, and then the transversal would be AC. So if I draw them outside of the picture, it would look like that. So since I have these angles congruent, this angle pair, they're alternate interior. And if you have alternate interior angles that are congruent, then that means the lines have to be parallel. So let's start out our proof. Writing down what's given to us. And now we just said that BC would have to be parallel to AD because you have congruent alternate interior angles. And that would be 1 and 4. So let's look at the other set of angles that we have. which is 2 and 3. So angles 2 and 3 are formed by line AB, line CD, and the transversal AC. If I draw that outside of my picture, it would look something like this, where those are also alternate interior angles. And since I have alternate interior angles that are congruent, that means that those sides that form them have to be parallel. So, AB is parallel to CD because we have congruent alternate interior angles. And those angles would be 2 and 3. So now I have enough information to say that ABCD is a parallelogram. That's what I wanted to prove. And the reason I know that is because both sets of opposite sides are parallel. Okay, so let's look at another. We're told that X is the midpoint of DB and AC. We're still trying to prove that ABCD is a parallelogram. So our goal is still the same as in that last problem, where we want to show that you have two sets of opposite sides that are parallel. So we're going to end with the same information that we ended with in this example. So these steps 2, 3, and 4 are going to be the same kind of steps that we'll show in this. So based off of the given, so we have our given, we know that dx is congruent to bx and ax is congruent to cx by definition of midpoint. Now I also have some vertical angles. I'm going to number them just to make it a little bit easier instead of having to use 3 letters quite a few times. So as we're going through this, we're going to prove that we have congruent triangles, and we're then going to use those congruent triangles to have congruent angles that we can use to show that we have parallel lines. So I know that angle 1 is congruent to angle 3, and angle 2 is congruent to angle 4, because they are vertical angles. Now if I draw some triangles outside of the picture, here to here, double, and double. This is A, B, C, D, and X. And we have another set of triangles. This is B, C, A, and D. And those are your vertical angles. So both of those sets of triangles are going to be congruent by side, angle, side. So we know that triangle AXB is congruent to triangle CXD, and also triangle BXC is congruent to triangle DXA by side, angle, side. So now what that does for us is allows us to use CP, CTC. So looking at the top and bottom triangle, this angle would be congruent to this angle. So let's give them some numbers, 5 and 6. So angle 5 is congruent to angle 6. And looking at the left and right triangles, those two angles would be congruent, so let's call them 7 and 8. Angle 7 is congruent to angle 8. And both of them are by CPC TC. So that means that AB is parallel to DC, and also AD is parallel to BC. And we know this because we have congruent alternate interior angles. So now I can end with what I want to prove. ABCD is a parallelogram because both sets of opposite sides are parallel. And that's it.